So we're gonna start, and welcome all to week 5 of Excode. This week is gonna be about having functions. So functions, I think, and I know I say that a lot, but functions, and people that already know a little bit of programming here can say that it's true, are really a big step. It's probably one of the last with packages that we'll also study today, foundational concepts you need to study in programming. When I add like kind of my curriculum that I worked on, I say, okay, that's the stepping point where you're like, okay, now you've seen all the fundamental, really the deep basics of programming. And after functions and packages, you can go into specialization routes. That's why originally this week was into more advanced programming logic. By reviewing it, I realized that I'd actually seen a lot of what I would have taught. So we're actually doing functions today. And next week, I'm doing something on popular demand, which is specialization routes on Python. I know a lot of you guys want to do, how can I make Python with, use Python to create websites or for AI or for something else? Obviously, in an hour, I will not be able to cover all of that, but I will go over the fundamentals of each, how can I apply Python to 3 or 4 specific fields to give you more of a direction. So this week, we're studying functions. I'm gonna spend the next 2 or 3 minutes to see what we should have done, which is advanced programming logic, but you're gonna see we already actually studied all of this. So originally, the deeper into programming logic was about Boolean logic operators. And so Boolean logic, it's really fundamental. It's simply in one sentence. You remember conditions. So when we add an if else, a while loop, use a condition, it is simply more advanced way of doing conditions, and that's it. Like one is doing not A. So if you have a condition A, you can say not A, and it's the opposite. So when the condition is true, you actually have it false, and when it's false, it's true. It's simply a way of playing with conditions. Or when you have 2 conditions, you can say A and B, and so it's true only if both conditions are true. And then you have, so this is only true if both are true. If one of the 2 is false, or they're both false, your overall is gonna be false. So it's combining conditions. Then you also have A or B, which is saying either A is true or B is true. So this means if one of the 2 is true, your result is going to be true. If they're both false, your result is going to be false. And then you can have code, and this is simply like an if else. That's how you can combine conditions. You can look at that on your own if that's really something that interests you, but I don't think it takes about 30 minutes. Just basically, you can see example like if condition 1 and condition 2, then if both of them are true, you run the code, else you run some other code, then you can combine it, like if condition 1 and not condition 2. Operators is the same thing, it's just a way of writing them as operators. So for instance, like these are logical operators, it's exactly the 3 we just saw, and or not. In Python, they're simply written in English. So if you say condition A and condition B, that's it. These are the symbols we can use in other programming language to represent those, but in Python, it's just English. We have other type of operators that you can use in conditions, but we already studied them all. It's just giving them a name for you to later retrieve them. So these are the logical ones. We got the comparison ones, which we studied last week. So A is bigger than B is more than C, or equality. Notice how we use a double equal to represent equality, because the single equal is already used for assignment operators, which we're gonna see later. We got arithmetic operators, which we already see, it's just plus, like 5 plus B, 5 plus 5, 5 plus B. These are examples, like A plus 1 greater than 3. This is just a way of making conditions that are not just if A is true, but it's like if A plus B is over 3, that's a condition in itself. And then assignment operators. The first one is equality, so it's to assign a variable. So it's like saying when you create a variable, we already saw that in week 2. So you simply create a variable and make it equal to something. These are all fancy ways of assigning something, but with just number 1, equality, which we studied. That's good, you can do everything. This is just ways of doing it faster. So that's it for operators. It was an example. There's other concepts that you can study also for doing more advanced conditional logic. I'm not gonna cover those because they're a bit more advanced. It's not really fit into a really beginner programming course. You can look into those. If you have any question or need to use those, I have material on those as well. I'm happy to provide. But mainly, if you got if else and you got loops, which you studied last week, you're good on the conditional, and these are not going to be on the exam. That's it for like of the 2-minute wrap up from last week. And like on the condition side is a bit just don't worry if you don't get everything. It's just the start. Now the actual week. And now we're going to get a little bit slower and study new concept, so studying functions. So we're going to do an introduction to functions, go again in the concepts of what's a function, and then do all the process. So from the analogy to then once you got the analogy, getting to a real world, so the real world example, then the generalization, and then examples in code. So starting, we're going to study the functioning of a vending machine, which is often used to represent a function. So let's study. First, you input a number, then you put some cash in. Then so you number the cash, and then you punch maybe a little bit, and then you got your food or your drink in there. So that's how a vending machine works. And from this, we can learn how a function works. So basically, we can see here, we take an input and we have an output. So the input is a number and some money, and the output is a drink. This is similar to what we saw in week 1, like input and processing and output. The difference is not actually the logic, which is still the same, but the way I make this logic. The idea is that the processing is going to be defined on its own, and then I can use it when I want for my input and output. So I create a function which does an action, and then every time that I need to do that action again, I'm going to call the function and say that's an input, and the function is going to give me the output for that specific thing. So I separate the processing, define the processing, and everyone in the world I want to use that processing can use it. Let's go back to the vending machine. I create my function. My function is my vending machine. So I build my vending machine. I have my vending machine here. And now everyone in this room can go to that vending machine, say, okay, here is my number, here is the money, and get a drink. So I define a general function, which is the processing, which is all the logic. So you put the number, you get all the logic. And then anyone else can do something which is called calling the function. So when you give some input to that function, you get out the output, even if it's much later in the code. That's why functions are amazing. Because if I need to do the same action 10 times in different places, like if I'm writing a finance software and I need to convert euro to dollar, which we're going to see, I don't have to do it every single time. So sorry, this was an example. Like I can put a different number and get a different drink, and the function is still the same, but people put a different input and get a different output. So coming back to our financial software, if I want to build a financial software and I have to do a lot of conversion, what I can do is create a function, which is here. Now we're going to see the syntax, which is called convert currencies. And every time I want to convert some value from euro to dollar or from dollar to euro, I just call that function. So I don't have to, for instance, do it every single time and do all the logic. Imagine for a much more complex thing. That's how it's saving us time. And so looking at this, now we kind of got the concept. I can add something else on a concept. If any of you did mathematics, it's really similar to a concept of a mathematical function. So if a mathematical function, if I have, x squared, well, I still have an input, and then I'd say like x equal to 2, so I do 2 squared, and I get 4. So it's just kind of a really similar concept. And as in mathematics, in functions, if you want to be a little bit more precise, you cannot have multiple outputs for the same input, but you can have an infinite amount of inputs. So that's a bit more the mathematical definition of a function. And that's true also in programming. For instance, I do a lot of engineering, and in engineering degree, we do maths, a lot of maths. And all our maths, it's tied to programming. And we represent our mathematical function, our differential equation, our equations, with Python functions. So we create a Python function, and then when you input a specific number, it's going to give you the y, so what the function does in Python. So that's how you can represent it. So that's how also, if you've done mathematics, you can conceptualize a function in programming. Coming back to this example, let's look at the syntax now. There are three things you need to look for in functions. So the first one, from a syntax point of view, is def. So def means I'm creating the function. So you can see here, we have def, so I'm defining a function. It's called def from defining. Then the second thing is the input, and the third thing is the output. And Python makes it extremely easy for us. When it says return, well, this is the output. It's just after the keyword return. The input is just here, just after the name of the function. So I say def, function name, so convert currencies. Here is my input, euro. I can have multiple inputs. I just use comma between each input. I can have an infinite number of inputs. And actually, there are applications with AI, for instance, where your input is going to be like 1 million inputs, because then you need to do advanced mathematics. Then here inside, you have your processing. So here we convert it to dollars equal to euro times 1.12, like random exchange rate. And then you can return the dollar. And here what happens is every time I want to call that function and use the thing, use the vending machine, I say function name, then I put the specific input I want to use. So this is a general input. This thing euro, and euro can be anything. But then when I have 10, I'm saying, okay, convert currencies. So convert 10 from euro to dollars. And what's happening under the hood, what Python is doing for us, is that it's taking that 10, going to the function which you remember. So when you define a function, Python is like, okay, I'll put it in this side of my brain, and I'll remember it for later. Then when you actually call the function, Python on its own, coming back to where you created the function, replacing the input euro with the actual number, is called a parameter, an argument. So it's the input you're giving. The actual name is argument. It's an input. So it's giving it inside of the convert currencies, replacing all our general thing, our letter thing, our variables, with the actual number 10. So 10 times 1.12, 11.12, then returning it, then coming back and printing 11.2. So that's the real point, the real advantage, is that it saves you a lot of time, makes your application much better, much more reliable. We're going to see in a while why. And then it also just makes coding so much easier, because if I make a function for doing something, like, I don't know, I did my node application, I'm going to take that example. A function is like filter node, takes as parameter the way I want to filter my nodes for a node taking application. And I just define that function once. And every time I want to filter my nodes, I just call that function is going to filter the node for me. If I filter node in 100 different places in my 10,000 lines applications, because nodes can be really complex, I just have one function in one file, and I just call it every time. I don't filter my node or define all the logic to filter my nodes in every single place in my code. It will make my code exponentially larger. I define it once, give it a name, give it some argument, give it an output, and every time I see it, I need it, I call it by its names, give him the specific nodes I want to filter, the specific way I want to filter that node, like alphabetically or by date. Then it goes here, it filters all the nodes, it gives me back all the nodes in a filtered way, and then I can print that to the user. But I only do it once, and then I can filter the node 100 times if I want to. So this is kind of it for the concept of function, which is the main concept of today. And the rest, for the next 10, 15 minutes, we're going to see examples. More specifically, we're going to see different concepts associated to functions. We're going to then use the functions in your workshop at the end. So too much functions kill the functions. The idea is because actually you're going to see there's plenty of concepts, and function can become really complex quickly. So what I'm going to do is I'm going to spend 1 minute on each concept, really give you a really easy overview. And then if you want, on your own time, you can go and look at more. The main idea is to give you like what you can actually learn from those things and what you can take out. Because this is more giving you how can we apply a concept like scope, which I'm going to introduce. How can you also apply it for thinking? Because this concept, then you can apply them for thinking general problems in life. So scope is important because scope is a way of creating variables. We can see we have global variables and local variables. So remember indentation. So when you create a variable inside of a specific block, like inside of a function, it's going to be declared only inside of that function. So here, these are global variables. So they are created like these. Here I create my variable, or here, or here and I say, oh, I want it global. So what happens here when I create global variables, I can access them in all my files. But just after I created them, do you remember in week 2, we're saying, oh, you cannot say what's inside of the box without actually putting the box there. So if I want to create a variable, I have to create it first. If I create a variable inside of a function or a loop or anything, it's going to be only accessible inside of that function or loop. So here, say variable declaration, there's an indentation here on the variable declaration. It's inside of the block. I cannot call this variable here because it's out of scope. That's how we call it. The example I like to give is Russian dolls. So if I'm in a Russian doll, I can see all the smaller dolls, but I cannot see out. It's exactly the same thing. A variable defined inside of a block can see all the blocks that are inside, and you can use that variable in all the blocks that are inside, but not outside. In an example, we can have some loops here. So we can see our mute variables for I in range, for j in range, for k in range. Here, for I in range, I is only defined inside of this block. If I then go down here and say print I, it's going to say error, variable is not declared, because I is only defined inside of this. Then j is only defined inside of this, and then k is only defined inside of this. So that's scope. It's important first because a lot of errors with functions are with scope. If you see an error, which is either error out of scope or error your variable is not defined or declared, make sure you define it in the right place. Not really for the workshop for today because they're simpler functions, but for instance, if you make the game for the game competition, you have a decent amount of variable, decent amount of functions even, it can get pretty complex when you have up to 100 lines of code. And if you start doing it the right way, knowing where all your variables are declared, then when it gets to 1,000, 10,000 lines of code, it's much easier, especially if multiple people work on a project. Now, flashing in some more concepts, which just quickly, function returning other functions, simply just, the name says it all. So you put return, you return other function. Callback functions is just putting a function after another. Nested function is a function inside of another. So just general examples I want to see what can be done, more advanced things can do with functions. We have closer, which is scope when you have function one inside of the others. Then you have function as variables. So for instance, you can assign a variable to the result of a function. These are all a little bit more advanced concepts I'm giving you quickly, just so that you have an overview of what programming is and what you can do with programming. You will not need all those things for the workshop. It's more like it's important to know these things. So function as variable is the fact that you can assign to a variable the result of a function. So if, for instance, I can say, if I have the square function, just like square something, I can say, create a variable called square of 4, then make it equal to square 4, and it's going to be 16. So my variable is going to be equal to 16. Then I have IFE, which is simply immediately invoke functions. The idea is when I create a function, I run it once. So back to my Node app, the idea was I have a function which is called render nodes. So it simply shows all the nodes on the screen. And so this function, I run it once at the beginning. So when the user loads the page, I run this function immediately. So it's immediately invoked function. And then every time that I need to do some nodes and render nodes, filter nodes, I say, okay, these are my filter nodes. Now render those, so show those on the screen in a different order or a different type of nodes, for instance, for a search. Lambda functions, it's important because it's what we usually use in mathematics. There's something called lambda functions, which is simply function in one line to represent a mathematical expression often. Modular programming is an important concept for the idea of when this, so let's do a pause. Modular programming is a bit out of the function, but it's the idea of when you code using function as modules, where every function can be put together to create an application. This is important because if you look at, for instance, some books called Clean Code or the NASA 10 rules, because if you have in specific places, you cannot fail. Like if you have NASA, when they fail, they lose hundreds of millions of people's lives, or in medical. So the idea is every single action is done as a function, and then I can put those functions together as modular, as block, to create an application. For instance, again to the node-taking app, every function does a specific action, like showing nodes, searching nodes, displaying nodes, filtering nodes, removing those, a function for each thing, then I can put all those together in a specific amount of place for then having my application. Another example could be mathematics. An example of bad programming is I need to solve an equation. I write some code to solve that equation. An example of good programming is I write some code to solve all equations, and then I use, obviously not all, but like all equations of that specific type, then I put it as an input, my specific equation I need to solve. It's much better, it's much more reliable, much stronger. And then the last concept is kind of a ride. It's called recursion. And recursion is the one I want to spend a little bit of time on because it's quite an important thing also in general, not only in programming, a way of thinking. So I need a volunteer, someone that's brave to come here in front and help. Can someone please raise your hand if you're a volunteer? Yeah. Thank you. So I think I'm going to do it here so that people online can see me. So we're going to do a game to illustrate why recursion is important. So can you see him? What's your name? Want to see it here?
Arhan.
Okay, thank you. So basically, the idea is you're standing here, and your goal is to reach this chair, okay? So we're going to start, and we're going to define a function, which is called a walk. And this function takes as an input the number of steps. If I say walk 1, what do you do? That's good. If I say walk -1, yeah, that's perfect. Filling up quickly. Now what I'm going to say is please estimate the distance between you and that chair. How many steps do you think you're going to need? Yeah, no, without walking, just looking at it.
5 steps.
Yeah, so I say walk 5 and you reach. So your goal is to reach, yes. 4, 5. Okay, that's good. And I come back to the starting point, so walk -5. And I ask you again, estimate the distance. So 5. Walk 5. Now you're broken. Your program is broken. But luckily, we got recursion. So now let's study how recursion can help us solve this problem. We're doing this completely differently. Rather than saying walk, we're just defining a much simpler thing. So we'll take a step. So take a step is literally just taking a step. So what I'm asking you is close your eyes. And in recursion, close your eyes, close your eyes. In recursion, what you do is you don't estimate the distance. You just say, if I'm arrived, I stop. If I'm not arrived, I do the same action again. Okay? So what it's going to do is you're going to close your eyes, take a step. Now, listen, and then you'll do it. Okay? So you close your eyes, you take a step, and then you look. Open your eyes, look. Is there the chair in front of me? If not, you close your eyes again, take another step, then look if the chair is in front of you. If the chair is in front of you, you just stop, okay? So close your eyes. Now recursion. So take a step, open your eyes. Is the chair in front of you? Okay, close your eyes, take another step. Is the chair in front of you?
No.
Close the eyes, another step. Careful. Is the chair in front of you?
Yep.
We won. You got it? Thank you. Thank you. So that's the concept. That's the idea. So rather than saying, oh, I estimate the distance, I need to walk, but then if there's changes, if this is in the middle, I break, I'd say I call myself. So it's a function that calls it itself. So when you say take a step till you reach it. So when I take a step, if I'm not reaching it, I still rerun the original take a step function. So here, so like def walk, we say take a step. So you take a step. If you're not arrived, you walk again. So you take another step. If you're not arrived, you walk again. You got? It's in circle. And that's like just really powerful. Because I'll give you an example. Factorials. So it is general way of doing it. Factorials. So factorials, if you're not familiar, if you say 5 factorial, it's equal to 5 times 4 times 3 times 2 times 1, 120. But one can realize that, sorry, the factorial 5 is equal to 5 times the factorial 4. The factorial of 4 is equal to 4 times the factorial of 3. So you can see here, factorial of 5 is 5 times. So it's recursive because every time you can do the same function. So here is what I can do. And it's much simpler in like literally I have 4 lines of code for something that's kind of complex mathematically. So we say, if we define a function which is factorial of n, we say, okay, if we are at n, we just return 1, so we're good. If we are not, we do n times the factorial of the one after. It's like saying, if I do factorial of 5, it's going to do factorials of 5 is equal to 4 times the factorial of 5 times the factorial of 4. Then factorial of 4 is equal to 4 times factorial of 3. Then factorial of 3 is equal to, so any number I have, I can do up to factorial of 1 billion. I'm still going to do step by step and reach the actual number. So every time I'm taking the factorial of the one after till I reach the actual thing. So that's how I have all my functions. That's an example of it. Packages are a concept we're going to study next week. Just put it up there just so that you can start to look at it, because you may need it not for the beginner and an intermediate section, but the advanced one, which is create your game. So just 1 second, the create your game, I got around 15 submissions, hoping to get another 5, 10. So please submit one, get a certificate. If you win, you're displaying our socials. So that's still the advanced bit. So that's why I put packages up there, if you want to look at it. And start using those in your advanced section. We're going to study this a little bit more next week. But basically, in one sentence, is the idea that you can use functions written by other people inside of your code. So you call them inside of your code, and then you use those. Like all mathematical functions, you don't have to create them. Someone else already did all of those. So you just say, okay, from this other code, import this package, and then I can use it. So this is the fundamental concept. Don't worry, it's not on the workshop. Next week, we're going to study this, because packages are actually really important when we start working with Python for AI or Python for actually applications. So that's it for the concepts of today. So we studied mainly, so first, advanced conditions, a way we can make more complex condition. The real deal was functions. So the vending machine, the idea is that define the processing in one side, then anyone can use that function, a specific input, and get an output. Then we saw plenty of concepts with functions. The only thing you need to remember is called recursion. So it's the idea that you can have a function that calls itself. So to have an iterative process, to do something multiple times, you just say, I'll do it, I'll go in myself, I'll do it myself. So it's always enter himself till you reach a specific end, a condition at the end. That's it for Excode. I got also an event I'd like to share that we're running for Global Entrepreneurship Week. So look, everyone look on your phone. Look if you got something to do on Friday the 22nd. Look, I'll do it in front of you. You go on your calendar, look, Friday 22nd from 10 to 1, even if you have a lecture in the middle. If you got nothing, well, I got something because I got this. But if you got nothing, got this event. So it's done by multiple societies and to extra entrepreneurs and actors, women in business, by visionaire, paid by the university. It's an event doing around entrepreneurship. And we're going to have a panel of speakers in the morning. I'll be there, so that's reason to go. There's also going to be speakers going to talk about the first step in entrepreneurship and more generally how to set up a digital brand. There's going to be a CV for attending. So people that attend are going to get a certificate, certificate in your CV. And then there's also going to be a pitching competition. If you want to pitch, you can pitch, or also if you don't want to pitch, you can just attend and vote who want to win. If you pitch, there's a £300 doing pitch trials this week, so you can try and put your idea, and if you get selected, you can go on stage and pitch for £300. But also if you want to attend, that's the QR code to attend. I really recommend it. Leave a second, you can take the ticket right now, or take it later. Really recommend taking it. And it's in Riedel, which is 2-minute walk from here. So that you can go and then come back if you have a lecture in the middle. And also the people online, you're also very welcome to join. Okay. So I hope I see a lot of you there. And for this week workshop is going to be a little bit about some exercises around functions, some general things, just trying to do in the beginner, just create some really basic functions. In the lecture code, I've put some examples you can look at if you need to. And then in the intermediate section, we're going to do a little bit more advanced thing. and then in the advanced section is still the game. So remember, if you want to have something on your certificate, you can also submit the game and you get a special thing. That's it. You can check in. Thank you for coming today. Next week, we're going to see some more advanced way of applying Python to specific fields. So like 10 minutes Python for AI, Python for web, so how to create website with Python, and then some other concepts. And I'll see you all next week. Thank you. Oh yeah, regarding the exam, I wrote a message on the WhatsApp. It's going to be over 1 week online on the Excode platform. So everything is going to be on the Excode platform. Next week is the last week in person, so all of you attend. And then the week after, you're going to have 1 week to do your exam online on the Excode platform on your own time.